All right. So we will go ahead and get started here. Talking about collaboration with Git tonight. So there's the site there in case you forgot, dcprog.club. Go join the meeting so we make sure that you're attending. Yes, it's hyperlinked to the website itself. I was too lazy to go change the color to blue, so I'm like, I'll just hyperlink it. So there you go. You're welcome. I'm being harassed for it and questioning all things, all life decisions right now. So anyway, so a little bit of a refresher. So if you attended the very first meeting, programming club this school year, we talked about Git then. And so the difference between like that night and tonight is first thing I was kind of talking about like Git, like the basics of it and like how to use it kind of as your own like version control and keeping track of your changes and stuff. So tonight we'll kind of dive more into that. How can I use it to work on code with others and seamlessly share things instead of like dropping all the code in a Discord and sending it back and forth, because I did that once with a section for a class, and that was not fun. Anyway, so that first meeting we talked about branches, commits, we talked about merges, just what they were. So to recap, a branch is these two things. So you see like this blue master, this green new feature. Yeah, my mouse is up there. So these are two different branches. All these little blue dots are commits, and commits are whenever you push up your changes that you made in your code, kind of like a save point, basically, is kind of what a commit is. It's like a save point. So this is kind of general basics. So we'll kind of dive, you see a merge happening right here. We'll dive more into those merges right now. So there's a bunch of different merge types, merge methodologies, techniques. These are three types that I've used. There's others, like I said, but these are kind of the ones that I like best. So the first one is fast forward. So this is basically just saying, so if you have your initial master branch and you make a new branch, to create some new feature, when you want to push those changes to your master branch, you can do what's just called a fast forward merge, and all that simply does is it moves that blue master, as you can see here, up to the same spot as some feature. So there's no like extra commit made when you merge, because sometimes when you merge, there's like another commit that specifically just says, hey, we merged these two branches together. There's no commit with this one. It just goes up to speed with your other branch, sort of thing. So as you can see, just kind of goes along the line there. You have a three-way merge, which is kind of similar to fast forward without the fast forward part. So this one actually does incorporate two different branches and makes one commit, signifying that both of these branches were combined. So as you can see here, we have two branches right now. We have our master branch, and we branched off and made like a new feature branch. And once we combine those two things there, we have our new master. And these two commits in the former branch are still shown and visible, like in your Git history, and show that they're branched off like that. It just kind of comes together and combines that. So if you want to be able to like track like when you made a new branch and you made new commits for a new feature, this is a nice way to merge it and still kind of notice or tell when you had another branch existing, if that makes sense. This is kind of a good visualization of it as well, kind of comparing the three-way sort of thing to just a simple fast forward. Three-way, when you have started out here and you merge these two branches together, it just makes a new one, and you can still see this feature branch existing. Or you can just, like we showed earlier, just choose to just go straight forward and turn these yellow ones just basically into blue ones, if that makes sense. So we also have what's called a squash merge. So what squash merge does is it's similar to like this three-way merge here, except that it puts all these together into just this one. So instead of these three yellow ones still existing after the merge, it just would be this 1, 2, 3. As you can see here, it would just make a new commit, combining all those commits into one central commit. So this is nice if you're working on a big project, or for example, I had a class project last semester where I made a commit. I had a bunch of different Windows forms that I was having to make, and whenever I would update like one form, I'd make a new commit. So if I just changed the design of things, I'd make a new commit, and then when I'd actually add functionality to those buttons and stuff, I'd make another commit. So I had a bunch of tiny commits, and so when I wanted to merge that back into master, I didn't want all of those commits clogging up my Git history sort of thing, so I just made one overarching squash merge that just said I completed step 2 in this commit, and then I just had one commit sitting on, or one extra commit sitting on my master rather than like 5.
In this diagram, are the arrows pointing backwards in time?
Yes. So that is, yeah. So this graph is kind of pointing at its parent sort of thing. So it's kind of backwards of the way you would kind of traditionally think of how it's working. So yeah, great question. So it starts at A, and then B, C, D, and then E, F. So the arrows should be going the other way, in my opinion. If that makes sense. So yeah, good question. So this is another example of just some of those merge types. Each have their own use for different scenarios. Sometimes it's not a good idea to use like a squash merge if you have a bunch of changes that happen that you want various like checkpoints shown. You don't want to just smash it all together and put it in. But other times, you might not want 20 extra commits added, so you will use a squash. So as with everything, certain things are better in certain scenarios. Situations are situational. So there's also this process of rebasing. So rebasing happens, for example, if you were to have like 3 people working on some type of project, and each of them made their own little branch here. Say there was 3 of these feature branches, and one person made some changes to this project that they're working on, and they merged those changes into their into the master branch. The other 2 partners that have their own feature branches here may want to pull in those changes that other teammate published to the code. That way that their code is fresh and up to date, and then their changes are stacked on top of that. So what you do for that is what's called a rebase, and it simply just replays or fast forwards your entire branch up on master. So as you can see here, originally feature was branched off of this first commit here on master, and then let's say 2 different teammates committed their changes here, and you want to get those 2 changes onto your branch. You can fast forward your branch onto these. It'll replay those changes and then keep those changes that you've made on that other branch still existing. It will stack them on top of those recent changes that are made. So I use this a lot doing a group project where we were touching a lot of the same code or using the same things where you would need to rebase because they would change something fundamental that we would need to update in our code with our changes before pushing it back in. So we would use that rebase. And sometimes you would run into what's called a merge conflict. And that's where you have like the same line of code in both commits are changed sort of thing. So what you have to do with those merge conflicts, you have to go through and kind of choose like one by one, like, okay, which version do I want to keep? So generally, the best way to avoid merge conflicts is that if you have a bunch of different partners working on a project, have each partner work on something different. So like say you're working on a website, have like Nick work on the home page, Aaron work on the meetings page. We'll just use the programming website for example. And then me work on the resources. That way, when you're pushing your changes, you won't have those conflicts where if Aaron and I are both working on the meetings page and we changed the font of the text in our meeting titles, if we both changed that font, we're going to have a merge conflict and we have to decide which one do we want to keep. So having a merge conflict isn't the end of the world. You just have to go through and figure out which one you want to keep. But sometimes it can be lengthy and tedious and stuff. So there's a couple different methodologies that you can follow when using Git. So when you're working by yourself, the need for branching isn't always as necessary. If it's just yourself, you can just publish straight to the master branch as you go along and just kind of keep your revision history that way. When you're working with other partners, it's not as easy and clean to do. You'll want to make those branches so that way you aren't completely changing the code for someone else when they're working on their changes and stuff. So there's a couple different workflows that various groups can follow. So one of them is feature branching. So this is a common workflow that's good for like small to mid-sized teams. And it keeps things nice and organized and separated. So basically, using programming website again for an example, if we wanted to add a new page to the website that predicted the Powerball numbers or something like that, we would that would be a new feature that we would want to create. So we'd make a new branch specifically for that feature, and then within there you would make your changes and then bring that back into the master branch. So it keeps things nice and separated and organized, but if it's not maintained properly, it can get muddy. Question?
How often is GitHub used in a professional setting?
Like GitHub specifically, or just things like GitHub? Well, yeah. I mean, a lot, I would say. You're pushing a lot of those changes up to the remote, and in a professional setting, you definitely want to be making a lot of commits and using it. It'll be, if you're doing things right, you're going to have version control on every project that you're doing, because just having that ability to go back, like track your changes, go back if something goes bad with your code or sort of thing, and just a bunch of different reasons that just add insurance to your code. If you are just willy-nillying, probably have had it where you're working on an assignment in like Tom's class or something, where you're working on something and you got one step of the problem done, and you go into the next step and you change some things, and all of a sudden it blows up all your code, and you're like, oh crap, how do I rewind and get back to a working state and then keep going? Without Git, you kind of have to scramble and just try and Control Z as many times as you can, although you can't do that in nanos or even more, SOL. Anyway, that's the whole tangent. I would say it's used quite a lot in the professional work field, with just many different reasons, and we'll kind of dive more into those different features, because is asking Git or GitHub? GitHub. So yeah, so we'll dive into more different features. It's more than just keeping track of your code, so we'll show why, but good question. So yeah, feature branching keeps things nice and organized, but if you don't maintain it properly, you can have a lot of these old feature branches just sitting around and getting stale and misorganized. So when you merge in those branches, you're going to want to make sure that you delete them. So an example of what that looks like is kind of right here. You have your master going along, then you make a new feature here, a new feature there, and just kind of whenever you decide you want to make a new feature, you just make a new branch, and then eventually you pull that back in, as shown with the yellow here. So there's also what's called Git Flow. So this basically just adds one more layer, quote unquote, to that feature branching style above. This time the master branch is solely used for releases. So this is really good for like that professional environment where you're building an app for an end user, or like say an app that's like on the App Store, like a game like Wordle or something like that. Like whenever you want to publish those releases and send a new update out, that's what that master branch will be used for. There's a development branch that's based off of master, and then those feature branches that we showed above are based off of develop, and then you'll merge into develop. So it kind of looks like this. These purple ones will be those releases. So you can think of these purple ones as being each of these commits is what hits the App Store. And then these orange develop ones don't hit the App Store, and so this is what you can use. Like say you want to add a whole new game mode sort of thing, but there's a bunch of little steps that go into it. Building those little steps that go into it will be used with these feature branches and merging into that develop. And then once you have a good, solid working product that you're ready to add in to the main code, then you can merge your development branch into your master branch. That's kind of along the lines of that feature branch, but just a little bit adds another layer to keep things clean and prevent non-working code from getting published out into the real world sort of thing. So we'll take a quick look at GitHub. So there's some nice tools that GitHub and other remote repositories use. So by remote repository, I mean kind of like, so Git itself is version control that you can install on any computer and use just locally on your computer to keep track of your files and your changes and your progress. Things like GitHub, Azure Boards, GitLab. Those tools are remote repositories where you can publish your files and your changes and all of your Git history. You can publish that up to GitHub, for example, and keep track of those changes in the cloud per se, and allow that to be easy way to share files with each other, as well as just keeping that source code accessible, so if your computer bursts into flames, you don't lose all of your files sort of thing. So we'll take a quick look at GitHub. So here's the page for our DSU Programming Club website. So this here is just the main code page. So these are all the files that go into how our website works. So going into like, I think it's source, components sort of thing. So you can see all the different pages we have here for our website sort of thing. So this is kind of where all that code exists. So you can also create what are called issues in GitHub. And so what issues are is just a way to kind of say, hey, either something isn't working in our code, like we found a bug, or we want to add like a feature or something. Although issues is mostly kind of like bug finding, but we kind of use it for adding features and stuff. But the nice thing with issues is, say, so here's a preview at some of the things we want to add to the website in the coming days or months or when we get to it. For example, like we'll show slide numbers on slides. Having where was I going with this? Oh yeah, that's my train of thought. So the nice thing with issues is that you're able to kind of add like status updates. So say like title is self-explanatory, but here's an update anyways. You can comment on that. So you can kind of give like status updates as to how the thing is going, or if there's more details you need. There you go. Your inbox will get pinged now, Aaron. But you can also link your pull requests into with your issues. And so what pull requests are is simply it's requesting to merge your branch into, like, say the master, for example. So say if we're back here in our Git Flow here, and we have this feature branch that we're sitting on right here, and we're ready to pull that into develop or merge it into develop. When you're working in a group of people, you'll want to kind of implement these pull requests sort of thing. So that way it gives the chance for your other teammates to review your code, make sure that it's good and solid and sound before just pushing it into develop and potentially breaking things. So you'll do what's called a pull request here, and we can take a look at this one that Blake used earlier when they were first building the website. So it'll show like your list of commits that you made. He only had one commit here, and then you can have conversation here as well. I don't know if you still comment even after it's closed. Looks like it. And so you can say like, you know, like, oh, there you go, like, Blake, your code is trash, but in a more constructively criticizing way, you know, because we're all about positivity in the world, and give pointers as to, hey, like, this line of code is a little bit, or like, what does this line of code mean? Like, why did you add it? What is it? What's the goal that you're trying to accomplish, sort of thing? And so kind of deliberate there, and then cutting to the chase finally is that once everyone agrees, like, okay, yep, I agree, this is good to go, you can pull it into development, then you can make that, and then simply it just merges. So really the basic thing about pull requests is that it's like asking permission to merge before you merge. So it's a big fancy word for just saying asking permission, basically. So you can set branch policies on your branches. So all these branches over here, say like you can set like policies on like your master branch that says nobody can directly commit to the master branch. Like you can only pull request into the master branch. So if you're like working on code and you're like, okay, I'm going to commit this, if you were like accidentally on the master branch, it could potentially really break things, you know, like if you're only working on a developmental step and you're using the master as a release thing, if you were to actually push there, you send a release out to the app store and it's like, well, this isn't, you know, working. Having a branch policy can help prevent that and be like, hey, you're on the master branch, you can't directly commit to here, you can only do a pull request in, and then that makes sure that you go through all the steps to make sure that you are intentionally publishing the code into the master branch. You can also set it so like certain people have to review it. Like if you had a manager on a project, like you can make it that they're required to approve it. You can have like a number of people require it. So like 3 people need to say, yes, I agree with it before it can be merged. A bunch of different policies like that. You need GitHub Pro for like those branch policies and stuff. So it's not in the free version, unfortunately, but like in the workforce, you will more than likely have, you know, that GitHub Pro or like Azure Boards uses those policies as well. That's what I used this past summer, that we had policies set so that, you know, branches can't get accidentally deleted or pushed into and all those things. So yeah, and you can also do checks and files changed. So like shown here, it shows all the files that were changed, so not just the commit, but it shows you exactly what kind of code was changed in those pull requests, so you can see exactly what is happening. So the red signifies lines that are deleted, green lines that are added, like so. Blue is just modified, right? So there's also this cool tool called Github Actions. This is known as Azure pipelines, like in the Microsoft environment. And then I don't know what, like if GitLab has something, but basically what GitHub Actions are is kind of stating, so say whenever you push into or whenever you merge into master, for example, whenever you merge, fire off these steps sort of thing. So say you're using it for that app store release sort of thing. Whenever you merge into master, you can say, okay, automatically ship this thing out to the Apple App Store and the Google Play Store. So we have one example of an action here that was used when Blake and Aaron and Nick, you were working on CodeBox. It's a project. You can ask them more about CodeBox if you're interested. But basically, they had it so whenever they would push to GitHub, it would run these actions. So it would essentially run what's called npm install, publish. There's some other things up here as well, but basically just run these commands that will automatically just do jobs for you. So say if you have like a testing environment set up, you can have that action to automatically run those tests, make sure that they all pass sort of thing. Many other applications that you can use with GitHub Actions or Azure pipelines or whatever resource that you're using. So the combination of all these things kind of help make the software development process nice and clean and organized. Gives things structure and make sure that things are, going along in the right direction and not just kind of a whole, cluster of just randomness getting pushed up and hoping that, so-and-so has the file with all the new changes, but so-and-so doesn't, and trying to figure out, this person should publish to the App Store, using Git. For all types of projects is very important to keep things just clean and organized, and so you will definitely get to experience it in the professional workforce wherever you are working, whether it's cybersecurity or software development. You will be interacting with Git and GitHub. I definitely understand that it's a weird thing to kind of grasp and understand and figure out all in one. It really honestly took me until this summer when I was forced to use it that I was able to kind of really understand all that goes into it. So like all things, it kind of takes practice with time and stuff, but it is definitely something that you will become very familiar with and use a lot, or at least should. If your company isn't, then there's concerns there, but yeah, so kind of going back to that question there earlier of is it used in the professional workforce, I would say yes, very much so. So that's kind of a brief overview, nothing really in depth, but a bunch of different ideas and ways of how collaboration is done with Git. If there's any questions, feel free to fire them off, but otherwise that's kind of all that I have for y'all tonight. I don't think there's any announcements to be made.
I put some Kaddish questions up.
Okay. So Kaddish questions are up if you want to check those out and do some practice problems. Let's see, and then I know that the REU, reverse engineering thing, is being advertised and stuff, to go check that out. We don't have any slides or anything for that prepared tonight, but I know they've been advertising that, so check that out. It's a cool opportunity for both majors, but specifically cybersecurity peeps. And outside of that, I don't have much of anything else. So thanks for coming. We will see you here again next week, talking about something. So be sure to stay tuned, and we'll deliver some awesome content for you next week as well. So